Today I discuss on important topics related to nonlinear space. I start from quotient space. In previous day we also discussed quotient space, and obviously quotient space would give definition and also gives quotient space how quotient space become norm space. Okay, so today I start from that. I start from here. Obviously this norm space become Banach space, and how this one become Banach space we discuss now. Okay, so we write this theorem first. Okay, that means how this quotient space become Banach space I discuss today. So here let y, here obviously if here we choose closed subspace y. Okay, because if quotient space be norm space, then this one is needed condition. So we choose here same thing, y be a closed subspace of a Banach space. Okay, of a Banach space x norm. Okay, then what happened? Then x quotient y be a Banach space with norm x. Okay, x quotient y equal to infimum of x plus y. Here y belongs to y. Okay, then what happened? Then we done our proof. Okay, we start from proof. We're going to discussion about that this x quotient y be a Banach space with norm this. Okay, now we write proof here to easily or do it. Okay, we know about that this x quotient y norm, okay, be a norm space, be a norm space. Okay, then we have to show that, then we have to show that it is complete. Okay, it is complete. So what happened here? We write it now. For this let this one xn be a Cauchy sequence in x quotient y. Okay, then what happened? Then for epsilon equal to half, there exists n1 belongs to natural number such that, okay, such that what? Such that norm of xm, difference xm, okay, norm of x quotient y less than half for all m in greater than equal to n1. Okay, then what happened? Then we write again for epsilon equal to half square. Then what happened? Okay, so we erase that portion and going to further discussion about that. We just write this one we take a Cauchy sequence in this quotient space and define in this way. Okay, if epsilon equal to half, then this one happen. Now we erase that portion and going to further discussion about that. Now for epsilon equal to half square, there exists n2 belongs to natural number with n2 greater than n1 such that norm of x n2 difference x n1, here x quotient y less than 1 by half square. Okay, then what happened? Then thus we write it here, that means in this way. Okay, we define thus for epsilon equal to 1 by 2 to the power k. Okay, there exists nk belongs to natural number with nk greater than nk minus 1 greater than n2 greater than n1. Okay, such that what? Such that here norm of x in k plus 1 difference x in k, here x quotient y less than 1 by 2k plus 1. Okay, for all k belongs to this natural number. Next, marked is this one, marked as 1. Now we also discuss those portions. Okay, thus there is a subsequence, there is a subsequence. Okay, here x and k of xn, thus there is a subsequence x and k of xn which satisfies 1. Okay, which satisfies 1. So what we construct a Cauchy sequence, and then for different value of epsilon we get a obviously subsequence of this Cauchy sequence. Okay, now we saw that what we now saw that this subsequence is convergent. Okay, then Cauchy and subsequence convergent, that means this sequence is convergent. Okay, we known about that in norm space this one is happen, so we done it. Okay, so first we now show that here x and k is convergent in x quotient y. Okay, now what happened? Now we write here let y1 belongs to x and 1 subset of x. We now select y2, we now select y2 belongs to x and 2 subset of x such that what? Such that here norm of y2 difference y1 less than 1 by 2 square. Okay, then what happened? Then we also going to another discussion of that. Okay, we is our portion. Sorry, here we write, we now show that here too. We now show that this one. Okay, now then we are then consider y1 belongs to this quotient space xn1. Okay, and obviously this one xn1 means xs1 plus y. Okay, in this way y2 belongs to this such that this one happened. Then we erase that portion and going to further discussion of that. Now for y2 belongs to xn2 subset of x. Okay, we now select y3. We now select y3 belongs to xn3 subset of x such that y3 difference y2 norm of this less than 1 by 2 cube. Okay, similarly we done it. Thus we have what? A sequence yk okay in x with yk belongs to x and k subset of x. Okay, such that here norm of yk plus 1 difference yk less than 1 by 2 to the power k plus 1. Here k equal to 1 to infinity norm of yk plus 1 difference yk less than equal to k equal to 1 to infinity 1 by 2 to the power k. Okay, this one is less than plus infinity. Okay, thus yk be a Cauchy sequence in x. Okay, not a problem at all. Okay, we define in this way. That means y1 belongs to this quotient space. This that means this class. Okay, xn1 and y2 belongs to xn2 dot 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 yk belongs to xnk. Then what happened? Then k equal to 1 to infinity yk plus 1 difference yk less than equal to k equal to 1 to infinity 1 by 2 to the power k and less than plus infinity. Okay, thus we have a sequence. Thus that means we going to be that here y k be a Cauchy sequence in X. Okay. Now we write here that since X be complete, since X be complete, then yn converges to y. Then yn converges to y belongs to X. Okay. Now what we that means to here we write we erase those portion and going to further discussion of that. Okay. খেয়ে প্রত্যেকদিন আড়াইটার সময় পড়ানো হয় না প্রত্যেকদিন মানে মাধ্যমিকের মেয়েটা প্রায় প্রত্যেকদিনই আড়াইটার সময় পড়ায় আমি কি তাহলে বলো আমি খাওয়ার পর খালা খালা দিই মানে খেয়ে দিয়ে ড্রেস করতে লেগেছে পুরোদিন খেয়ে দিয়ে 10 মিনিট শুতে লাগে আরে 3 দিন তো সপ্তাহে আছে তো 3 দিন সপ্তাহে আছে বাদ বাকি সময় তো মানে খেলাম খেয়ে দিয়ে here we write note that okay 5 দিন তো হয়েই গেছে norm of x and k difference y here x quotient y equal to norm of x and k difference y. Okay. Norm of x norm y equal to what? Equal to infimum of z belongs to y. Norm of x and k difference y plus z. Okay. Less than equal to here norm x and k difference y plus z. For all z belongs to y. তারপরে আজকে থেকে করার কথা আমি কাল থেকে করার কথা এবার কালকে যদি আমি গোলাপি ছবিগুলো পড়াতে যাই তাহলে কালকে মন করে we write it or mark it to এতদিন মনে হচ্ছে আর নালে একদিন okay then what happened then we write here that means here yk belongs to x and k implies that yk equal to x and k plus zk. Here zk belongs to this y. Okay. Then what happened? Then obviously we write it again. Here zk equal to difference x and k plus y. Okay. Then what happened? Hence from 2 we get what? Here 0 less than equal to norm of x and k difference y. Okay. Here x quotient y less than equal to here we write x and k difference y plus y k difference x and k. দাদা খুব সুন্দর হয়েছিল ঝাল then we're going to forward discussion of that. Okay. Then we write here in this way this equal to what? Y k difference y. Okay, that means x and k. Here we write that means zk and then we here define this one is minus x and k minus y. Okay, because y k difference x and k this zk. Okay, this one we put here, and then we get this one. Okay, then what happened? Then obviously this yk belongs to this class x and k, and yk difference y. Okay, so this one converts to 0 as k tends to infinity. Okay, then what happened? Then we again erase our portion, then we write that here. Thus this x and k converts to norm y in x quotient y. Then xn is Cauchy in x quotient y, and here x and k converts to norm y in x quotient y. Okay, then this implies that what happened here, x in converges to y. Okay, in x quotient y. So x quotient y be a Banach space. Okay, so what happened here? Here too much difficulties arise. Okay, first we construct a Cauchy sequence in quotient space, and then obviously we that means we write some subsequence of Cauchy sequence x, that means class xn to class xnk. Then we obviously shows this subsequence convergent. How this subsequence convergent? That means y1 belongs to xn1 subset of x. Okay, we now select y2 subset belongs to xn2 subset of x. In this way we write here, that means some sequence yk, and this one k equal to 1 to infinity norm of yk plus 1 difference yk. Okay, less than equal to k equal to 1 to infinity 1 by 2 to the power k. Okay, this one obviously less than infinity, so yk is a Cauchy sequence in x. Okay, and since x be complete, then yk converts to y in x, and then note that this one that means class x and k difference class y, obviously x quotient y. Okay, with respect to, then this one happen, that means less than equal to norm of x and k minus y plus z. Okay, so we construct from that. That means some yk belongs to x and k means x and k plus zk, and then obviously zk gives some value, and obviously zk belongs to x, so we from 2 we get that. That means x norm of x, norm of class of x and k difference class y obviously tends to 0. Okay, so this gives class x and b Cauchy and class x and k convergent in quotient space x quotient y. Okay, then what happened, then xn, that means class xn converts to class y in this quotient space, so x quotient y be a Banach space. Okay, so today we stop here. If you get this type of videos, then obviously subscribe my channel, and if you like this types of video, then please give like, and if you have any questions, you tell me in comment box. Okay, so I stop here.